Hey y'all, today we're going to be talking about graphing linear inequalities. Just as a reminder, the difference between an inequality and an equation has an equal sign in the middle. An equality has an inequality sign, meaning one side is greater than or less than, or of course equal to the other. So let's follow with what we know. Example 1, we're going to graph the following equation. Y is equal to x minus 1. So remember, for graphing a linear equation, we need to label two things, our slope and our y-intercept. So our slope in this case would be equal to the number in front of x, which is just 1. Sometimes we're lazy and we don't write it. And then our y-intercept is, of course, the number after x, which is -1. So b is equal to -1. Because remember, all linear equations in slope-intercept form are of the form y equals mx plus b. And that's the form that we really want to use to be able to graph. So from here, we start by plotting our y-intercept, which in this case is -1. So I go and I put a point right here at -1. And then I use my slope, which 1 is the same as 1 over 1. And remember, our slope is rise over run, or change in y over change in x. So from my y-intercept, I rise by +1. And then I always go to the right. So if my y is positive, I go up. If my y is negative, I go down. But my run, my number on the bottom, I'm always going to go to the right. So up 1 to the right by 1 to get my next point. And then I can just keep repeating my up 1 to the right by 1 to get some more points. And then once I feel like I have enough points that I can graph it, I can go across and add in my nice line, with, of course, arrows on the end to denote that it continues on forever. So now, same idea, but let's graph the inequality. So we have y is greater than or equal to x minus 1. So same exact slope value, m is equal to 1, which I'm going to go ahead and write as 1 over 1. Same exact y-intercept, b is equal to -1. Okay, but the last thing that's different is this greater than or equals to, and that is going to be important, but we're going to talk about it at the very end. So first off, we start by putting our b is equal to -1, our y-intercept on the graph. So same exact spot. Then I'm still going to get some more points using my slope. So slope is 1 over 1. So up 1 to the right by 1. And down 1 to the left by 1, if I want to go in the other direction. Okay, so now this is where an inequality differs. So with an inequality, you have to decide if you're going to graph a solid line or a dotted line first. Solid line is when you have an equals to in your inequality. So solid line is when your inequality has an equals to. So we make our line solid when we have the line under our inequality. So line under the inequality, solid line. So over here on the left, we're going to graph just like normal. Nice solid line like we normally do. And the reason why is because if y is greater than or equal to x minus 1, then that means any solutions can be on our actual graph. Okay, so that's why we put a solid line, because that means we're including the actual line the graph goes through. The second piece is which direction our sign is pointing. So we have a greater than. So greater than means we are going to shade above. Because I want y values that are greater than the line x minus 1. So because I want y values that are greater than, I'm going to shade greater than my line, or up above. So greater than means shade above. Less than, of course, would mean shade below. So I'm going to go here, and y'all have this too, this little highlighter tool. We can come in here and just shade all the portion of the graph above my line. So what that means, because when we graph an inequality, so remember when we graphed an inequality before, we did on the number line, and it was just what numbers could make this inequality true. So we'd have an X number line and we'd pick a number along that number line. So anything greater than 4, anything less than or equal to -3. Okay. What this shading means is that any points within this shaded area would make this inequality true. And I just want to show you this really, really quickly. So let's just pick a random point. So like this point right here. Okay, this is y value of 3, x value of 1. So this point is 1, 3. If I plug these values into my inequality should still be true if I shaded correctly. So plugging into my inequality, we would get 3, because that's my y value, is greater than or equal to 1 for x minus 1. So 3 is just 3, so 3 is greater than or equal to, 1 is 1 minus 1, which would be 0. So is that a true statement? Is 3 greater than or equal to 0? It is, okay? So that means I shaded correctly because I could pull any point. So I could pick any point in the shaded region and plug it into my equation, and the inequality should still be true. So that's what it means when we shade in. We're saying that any points in this region would still be true for that inequality. Okay, so let's look at another one. So graph the inequality, 3y is less than 9x minus 3. So just like being able to graph an equation, to graph an equality, we want it to be in y equals first. So this one we have to do just a little bit of an extra step. Divide by 3, divide by 3, divide by 3. So that gives us y is less than 3x minus 1. Then from there, we want to do the same things. Decide our slope and decide our y-intercept. Y-intercept is -1. Slope is 3 over 1. Then from here, we're going to add in our y-intercept first. So y-intercept is -1. So nice big point right there at my y-intercept. Slope is 3 over 1. So I'm going to rise by +3 and run by +1. So go up 3, 1, 2, 3, up to 2, to the right by 1, put a point, rise 3 over 1, same thing in the other direction. Okay, now before I put my line, okay, now I have a less than symbol. So less than means two things. First of all, no equals to means a dotted line. So because I don't have an equals to, I'm going to put in a dotted line instead of a solid line. So I want to mostly follow as well as I can and just add in that dotted line there along my points. So notice the difference. I want you to see, because it should be pretty obvious. Dotted line makes it seem like the line's not really there, right? Solid line makes it seem like the line is there. So if it's an equals to, we do a solid line. If it is a less than, we do the dotted line, okay? Next piece, just like we did on the last one, because this is less than, so less than, we're going to shade below. Oop, not below, below. Okay. So below, we go down below our equation. So that's going to be all this region down here. And obviously, you do not have to be perfect at coloring this. Okay. And so same thing should be true if I plugged in any point in here. So let's just pick one nice easy one. So we'll do 3, 2. Oop, not shading. Well, now I undid all my shading. There we go. So if I picked any point in here, so like 3, 2, I could plug it into my inequality, and it should still make my inequality true. So 3, 2, I'm plugging it into my top inequality. So 3 times 2 is less than 9 parentheses 3, and then minus 3. So all I've done is replaced x with my x value of 3 and y with my y value of 2. So from here, 3 times 2 is 6, which is less than 9 times 3 is 27 minus 3. So 6 is less than 24. Okay, that statement is definitely true. So I shaded the right part of my inequality. So that's a nice little check you can always do if you're unsure if you shaded correctly above or below, and vice versa. Okay, so let's look at one last one. Number 3, we're going to graph the inequality negative 4y minus x. Okay, once again, we got to solve for y first, so add x to both sides. So that gives us negative 4y is less than x plus 4. Then divide by negative 4, divide by negative 4, divide by negative 4. Cancels out over here on the left. So we get y. Then we divide by a negative, so instead of this being less than, remember, that flips around and becomes greater than. X divided by negative 4. 4 doesn't go into x evenly, so we can just write that as negative 1/4, because that's technically the number that's up here in front of x. 4 goes into 4 evenly, and then it, of course, becomes negative 1, and that's a gross x. We're going to write that again. All right, and there we go. Y is greater than negative 1/4 x minus 1. So I moved my x over. I divide by negative 4, which switched my inequality. So now I can grab my slope and my y-intercept. So slope is negative 1/4. Y-intercept is negative 1. And remember, with our slope, we always give the negative to the top number, just to the y value. Okay. So as I'm graphing, once again, y-intercept first. So b is equal to negative 1. So plop a nice little y-intercept right there. Then my rise over run. So I'm going to rise by negative 1, which means I'm going to go down. So down by 1 to the right by 4. So down 1 to the right 1, 2, 3, 4. Down to the right, ran out of room. Up 1 to the left, 1, 2, 3, 4. And same thing in the other direction. Okay. Then once again, I have to look at my inequality to know how I'm going to draw my line and how I'm going to shade. It's just greater than. So just greater than, no line underneath means it's going to be dotted instead of a solid line. Of course, with my arrow still on the end. And then as y is greater than, so greater than is going to be shaded up above. Just like that. And once again, it does not have to be perfect, y'all. Okay, and just to check, because I always think it's good to check to make sure we are correct. Okay, we can plug in, it doesn't matter which point. Oop, undo that. But we can pick any point here. So let's pick a nice easy one. I'm going to pick the origin, 0, 0. Okay, and we can plug that point into our original graph. So negative 4, parentheses 0. We'll write our point just for those of you that might need it. So negative 4, parentheses 0, minus 0 is less than 4. So negative 4 times 0 is 0. Minus 0 is less than 4. So y'all tell me, is 0 less than 4? It most certainly is. Okay, so we shaded correctly. So go us. And we even plugged it into the original just in case we might have made a mistake in our solving, just to check. Okay, so that is graphing inequalities, y'all. Like I said, the big thing, it's graphing a linear equation like normal, but the two big things that we're adding is whether it's going to be solid or dotted, and then which way to shade. So just to kind of help us remind ourselves. So shade above with a dotted line is going to be our greater than sign. Shade above with a solid line is going to be our greater than or equal sign. Shade below with the dotted line is going to be our less than sign. Shade below but with a solid line is going to be less than or equal to. So just a reminder, solid line is the equals to, that extra line underneath. Dotted line is just the less than or greater than. Shade above is going to be your graters. Shade below is going to be your less thans. All right, and that covers in its entirety graphing inequalities.